Today we're going to talk about observations, inferences, and hypotheses. If we take a look at this picture, the man in the picture is making an observation. It's noticing and describing an event around us. What is he noticing? Obviously he's using some kind of equipment that you might not be familiar with. It's called a sextant. And that particular tool is used to look at the stars and find your coordinates to help you navigate. When thinking about observations, I like this quote. It says, think something that nobody has ever thought yet while looking at something that everyone has seen. You have to be inventive with observations. You have to be detailed. And you have to be very, very specific. Observations are the first step a scientist takes along the path of looking at something and creating an experiment. Go ahead and pause your video and make 5 observations on this picture. What observations did you come up with? You might have said something simple like, there is a duck in the pond. You might have added a little bit more to that and said, the duck is making waves as it moves through the pond. You might have said, I saw a bird flying in the air. You might have made the observation that there are some plants growing next to the pond and that they're a little bit larger than the plants growing farther off. All of these are good observations, every single one of them. But let's go ahead and zoom in on this duck. Let's look at what this duck is doing. Of course, a simple observation could be the duck is swimming in the water. I like to add specifics though and say the duck is swimming towards me. You can clearly tell that he is coming in this direction. So the duck is swimming towards me in the water and he is creating a V-shaped wake behind him. That's a very good observation. All good observations need to hold some detail. So go ahead, pause your video and make another 5 observations, but make sure they're detailed. If you take a look at this picture, the first observation that I see is that something is wrong. We're all familiar with the car, so you might have said something like, there is a car, and here's the car. There is a person in the car, there's the person. You might say the person looks worried, although the picture isn't clear enough to see that, but you can easily make the observation that there's smoke coming out of the car. All of these are observations you can make. I'm going to make an observation, and I'm going to try to include a lot of details to make it a good observation. I'm going to start by saying, there is a car on the side of the road. You can clearly see, car on the side of the road. That car has a person in it. Its hood is up, and smoke is coming out of the car. All of those add good detail. What else could you add? The car is red, has a gray bottom. You could add those details if you'd like. The question I have for you is, why is this car on the side of the road? The answer to that question is an inference, which is a logical interpretation based on what is already known. In your life, you may have seen a car that's on the side of the road. You use something you already know to apply it to a new situation. That's called making an inference. Go ahead and pause your video, make some observations about this picture, and then make an inference as to what you think happened. If I look for some observations, the first thing I'm going to notice is the roof is ripped off of this building, whereas the side of that building is ripped off, and some debris has been blown around. All of those would lead me to say that this probably was a tornado. Did you come up with the same inference? Do the same thing with this picture. Make observations and then come up with an inference as to what you think happened. What observations did I come up with? Well, the first thing I noticed was there was water, and I don't see a body of water of anywhere else. In fact, in the background I can see some mountains, so we're probably inland somewhat. I can notice that cars have been moved. These two have been stacked on top of each other. Other cars have been moved into fences, and there appears to be some vegetation damage, whereas these trees have been kind of pushed around by that water, and this one appears to have sustained some small damage. What did you come up with? This was a tsunami, a wave that crashed and moved all of this debris. Go ahead and make some observations here, and then come up with an inference as to what happened. What observations do I come up with? Well, the first thing I see is that this is a potted plant. Nothing special there. The second thing that I start to notice is that the leaves on this plant are withered. It appears to be very dry at the soil. So my inference would probably be this plant wasn't watered. But if we take that inference a step further and make it into a hypothesis is an explanation for a set of events that can be tested. Very important that a hypothesis can be tested. It can also be disproven. Very key that you can both test and disprove a hypothesis. If you're making hypotheses, most of the time they're in if-then statements. Notice down here, if I water my plants every morning, then they will grow well. That is a testable hypothesis, and it can be disproven. For instance, if you watered your plants every morning and then they died, you've disproven your hypothesis. Go ahead with this picture, make your observations, then make an inference as to what you think is going on, and then finally make a testable hypothesis that you could use. What observations did you come up with? The first observation I came up with is that this is some kind of plant. You can clearly see that it's a leafy structure. And then I noticed that there's a fly either in or stuck inside this plant. This particular plant seems to be closed. If you look at the tube shape, it's similar to that one. All these lead me to the inference that perhaps this plant is a carnivorous plant. So my hypothesis might be, if this plant is carnivorous, then it will capture and kill flies. Testable because we can take this plant, put it in a controlled setting with flies, and see if it captures and kills them. Scientists start with observations. That's an objective view of what's going on around the world. Then they make inferences based on what they know. That gives them an explanation. Then they come up with a hypothesis, usually an if-then statement that explains what's happening, is testable, and can be disproven. All those together make up that hypothesis.